Hey guys, so today we are starting this new series which is called Physics Under 5 Minutes. In this series, I will be covering the A-level syllabus, including the AS and the A2. We will be dividing each chapter into small subtopics, and today we're doing measurement of physical quantities. Firstly, what is a physical quantity? Now, physical quantity is defined as a quantity that can be measured and is expressed as a product of a number and unit. The first important thing to note is that this quantity can be measured, which means we can measure it using our daily instruments, for example, such as the meter rod. We can use the meter rod to measure any sorts of lengths. Similarly, we can use our stopwatch to measure any sort of time interval. Therefore, the first important thing to note is that a physical quantity is a quantity that can be measured, and for that we need instruments. The second important thing to note is that it can be expressed as the product of a number and a unit. For example, this length of 100 meters. This consists of a number, which is 100, and it consists of a unit, which right here is meters. What this means is that, in other words, a physical quantity has a magnitude and a unit. This right here, meters, is the unit for length, and 100, the number, is the magnitude. Let's move on. Firstly, we have some base quantities in our physical world. And using these 7 base quantities, we can derive any quantity in the world. For example, the first one is length. The base unit is meters, and the symbol for that base unit is the small m. Secondly is mass. The base unit is kilograms, and the symbol is kg, which is small k and small g. The third is time, which is in seconds, small s. The fourth one is temperature, which is Kelvin, capital A. The fifth one is current, which is amperes, capital A. And we have amount of substance, which is measured in moles, and the symbol is mol. And lastly is the light intensity, also known as luminous intensity. And the base units for this are candela, with the symbol being CD. Now, these are the 7 base quantities, and using these, we can derive any formula in the world, and we can, in fact, reduce any other quantity and its units to these 7 basic units, and we will see how that happens. We will, in this syllabus, focus particularly on the first 5. You would also be wondering that, well, we also measure length in centimeters or millimeters, and we also measure mass in grams or pounds. Then what's this entire game about? Why are we specifically referring to these units? And the answer is these are known as their SI units. Now, what are SI units? SI units is an international system of measurements that we use universally in all scientific work in order to avoid confusion within units. What do we mean exactly by this? Now, let's say that I'm from Pakistan and I make this research paper where I use some unit for length which I've made up myself. Let's say KD, or let's say I use millimeters for that matter. And then you are someone who is residing in Japan and you're thinking about your own research paper, or maybe you receive my research paper and you start working on it. And when you start working on it, you wonder what KD exactly is. Now, in order to avoid this difference within units when we refer to our scientific work, what we did was that we came up with an international system of measurements. And we set what we call as the SI units for each quantity. For example, for length, we chose meters, for mass, we chose kilograms. And this is how we keep everything constant and leveled even in different parts of the world. Now, here are the examples of derived quantities. Derived quantities are quantities which can be derived using those 7 basic quantities. And the best thing, and I think the most amazing thing about basic quantities, is the fact that there are only 7 of them, and using them we can use and make up any formula in this physical world. Now, let's see some examples. Now, how about volume? Now, volume we know is L cube. Now, what is L cube? It is the length to the power of 3, or length into length into length. So we came up with this another quantity, volume, which has the unit cubic meters, just by using the base quantity length. Similarly, we have our quantity known as speed, which is measured in meters per second. And for this, all we have to do is distance, which in other words is our length, divided by time. So we use only meters and seconds, and this is how we derive our speed. Similarly, let me talk about another one, which is weight. Now, weight is also a derived quantity. It is m into g. Now, m in this case comes from mass. But what about g? Now, whenever you see such a scenario, it means that even this g itself is a derived quantity. And in fact, it is measured with meters per second square. So, in other words, derived quantities come from the multiplication or division of base quantity. For example, volume comes from the multiplication of length 3 times with itself. And you can also say that derived quantities are physical quantities which are formed by either multiplying or dividing the base quantities, and in most cases, both operations are used. Examples are speed, volume, and weight. Now, this is as of yet. In the next video, we will learn how to reduce our derived quantities units and express them in SI base units, which is a very important part when it comes to AS MCQs as well as the paper 2. So, till next time, Khuda Hafiz and bye bye.